out. So this one gives you your range. Your restriction here is 0 to 2 pi, so the entire unit circle. And we know. Oh, okay. Now it starts. Okay, I started too early. I didn't realize it didn't start recording it. Anyway, so we're using from 0 to 2 pi the entire unit circle. Sine, cosine, cosecant, secant. The period is 2 pi. So generally speaking, those only have one solution, but tangent, the period for tangent and cotangent is just pi. So if we're doing a full rotation on a unit circle and the period is pi, we're going to see two answers in one full rotation. Come on. Body. Go. She cries until she is allowed to be in my lap. Oops. Hang on. Okay. She likes being wrapped up. I don't know why. Sorry. So again, tangent. The period is just pi. So when I'm giving you 0 to 2 pi, we're going to see two answers in that full rotation. Caitlin says it's 4.55. I think that's what she meant to write. Yep, 4.55, but I wanted to the nearest thousandths, which is 3 places. Yeah, so those are the two answers. Let's see how we get there. First step, what do we do? And this is from yesterday's stuff. Divide by 4. Yeah, that's pretty easy. All right, now what? Inverse tan. Yep. So we do the inverse tan, and we get 1.404. Converting it to degrees just so we can, so we can understand where it is. Seeing 1.404 and looking at your unit circle that doesn't necessarily have things labeled as decimal, like 0 to pi, which would be halfway, pi over 2, which is 0.5 pi. So we don't have those converted to decimal, so it's easy to look at. But when we convert it to degrees, seeing 80.46 degrees is, we can visualize that in our head, saying, hey, that's quadrant 1. And that's really what we wanted to get out from this part. We're not using the degrees other than just telling us where it is, if that makes sense. So we are in quadrant 1. I'm going to draw the line. So here's, we'll say that's about 80. It's about 80 degrees. That's weird. Okay, so that's about, so that's 1.404. Is that what we said? 404, yep. So 1.404. So there's your first answer. That satisfies this. But because tangent has a period of pi, we're going to have, in this full rotation of this unit circle, we're going to have another answer. And that answer is a mirror image of that. So, well, it's going to be in quadrant number 3. And that's how tangents are. So in quadrant 1, tangent is positive. In quadrant 3, tangent is also positive because x is negative and y is negative. And remember, tan is y over x. In quadrants 2 and 4, we know that tangent is negative from past problems. So we need to figure out the other angle. So we need the angle from here all the way around to that angle. And, geometry, these diagonal angles are the same, right? So the pen doesn't want to work today. So that angle is also, well, that reference angle it's called is also 1.404. So we have to use, from unit 3, you're given those 4 scenarios to calculate your actual angle from reference angles. But looking at this, what is that formula that we can use to actually calculate that red full angle? What do we do? So Chloe says, add pi to it, and she would be correct. Which kind of makes sense because if it's a half rotation is just pi. So if I know it's 1.404, just add pi to it, right? That works. Another way, actually, that is the only way. All right, so there's the first answer, and then there's the other one. So you take your pi and you add 1.404, and that's how we get 4.546. That's the other answer. So you don't necessarily have to memorize those formulas from unit 3 of taking reference angle and to figure out the other one in this case. If you just draw a picture, the picture should kind of tell you what to do. And then underneath this last blue box, I just have this, and this is rounded work, and this is what we want to avoid. Even though in this case, the answer is the same. So whether we actually use the exact, which is inverse tan of 5.95, versus the rounded work, which is 1.404, the answer is still the same. You just don't want to do that. You never want to round your work if you can avoid it. Sometimes you can't avoid it. But we can't avoid it here. So this is from yesterday. All right. Any questions before we go on to today's lesson? All right. Oh, by the way, the deadline for Raise My Grade, if you're actually watching this right now, the people who are watching the recorded session, which I guess now they're requiring you guys to come to these live sessions. So, and you get points for that. Anyway, you have until noon today to submit the assignment if you want to do Raise My Grade to retake one of the first 3 exams. So a lot of you have already done it. And if you submitted it, you're good. But noon is the deadline. So get that done if you want to do it. I sent an email out some days ago. All right. So today's lesson, this is day 2 of 4.04, general solutions to equations. So we're going to solve trig equations just like yesterday, but now we're going to, we're going to have no boundaries, it says. So this is basically the same thing as yesterday with just one little easy piece added to the end. And it's easy. So it's yesterday plus an easy piece, which still makes it hard, right? All right, we're being recorded. All right, general solutions. All right, so unit circles. We have an infinite number of solutions when talking about trig functions, because we learned about coterminal angles. You just keep doing the full rotation, whether it's pi or 2 pi or whatever the period may be. So, that's why we have restrictions. Like yesterday, the restrictions on all those example problems was 0 to 2 pi. On your modules, they might say like 0 to pi or even 0 to pi over 2 or whatever it may be. All right. So for these, um, we are not going to have restrictions today. So that's where the general solution form comes into play. All right. And it's as simply as this line right here. So for sine, cosine, cosecant, secant, all you're going to do is to the end of your answer, you're going to add plus 2 pi n. And then if it's tangent or cotangent, you're just going to add plus pi times n. And n is an integer. Remember, integers are plus or minus values, including 0. So this just basically takes into account all your coterminal angles, whether you're going forward or backwards. N could be 1, n could be 2, n could be 3. Okay, so let's go ahead and solve this. Everyone, your paper. This is the same as yesterday. So we have 3 equals cosecant squared plus 1. Let's go ahead and everyone solve this. I'll give you 2 minutes to take a whirl at it. 2 minutes. Feel free to, if you're stuck, maybe ask in chat and someone might be able to help you out. Another 34 seconds. Oh, by the way, if you are curious, I am adding your participation points at the end of the unit. If you were wondering. All right, time is up. Okay, anybody able to finish this problem? Do we round? So your answer should be in terms of pi. So if you don't have pi in it, it's probably wrong, maybe? If you're using an iPhone to do this math, you're definitely wrong. All right. Anybody have an answer to this? So Caitlin got pi over 4. Any other answers besides pi over 4? So you should be using your unit circle for this. Yeah, I believe you should have 2 answers, but I could be wrong. Emily, you're probably right on that one. It's probably not that answer. So we should probably have 2 answers. So don't forget when you do the square root, don't forget plus or minus. So maybe that's where you lost your other answer. Maybe. I don't know. All right, what's our first step? What is the first step? And yes, pi over 4 is one of the answers. We are going to subtract 1 both sides. I like that. Now what? Now what? What do we do next? So there's a couple things. Okay, so Antonio used one of the identities to make it 1 plus cotangent squared. Antonio, that I think if you kept going with your thinking and then you change cotangent to tangent, 1 over tangent, um, eventually you should get to the same answer, just in a kind of long drawn out way. But what you're doing, it's mathematically it's not wrong, but you're definitely making more work for yourself. Right. So, square root. Yes, we can square root both sides. Um, I kind of wish I would have done that first, actually, but I didn't. So, I I personally changed cosecant to sine, but you don't have to do this step. You could actually square root both sides first, and then change cosecant to 1 over sine. It that order doesn't matter in this case. So I made cosecant squared 1 over sine squared, and then I swapped the 2 and the sine squared, a little math trick. So basically, I divided both sides by 2 and I multiplied both sides by sine squared. That's what I did. Um, Shortcut, I just swapped the diagonals, same thing. And this is where I square rooted. But again, you could have square rooted 2 steps before that, um, and maybe saved. Well, I wouldn't say saved. You probably would have the same steps regardless. So square root both sides. Square root the top, square root the bottom. Don't forget plus or minus. Don't forget you have to rationalize. So 1 over radical 2 becomes rad 2 over 2. So I did not show my work because all of you should know how to rationalize the denominator by now. So I just went right to the what it is. Everyone good so far? All right, all right. So now you do the. Oh, I didn't show it. You want to do basically you're doing inverse sine both sides, right? So the question is, what is the angle when your y value, because sine is y, when y is either plus or minus radical 2 over 2? Ooh, I'm actually missing some of my answers. So when sine is positive, rad 2 over 2, we should have pi over 4 and 3 pi over 4. And then when it's negative, add 2 over 2. Then you have your 5 pi over 4 and 7 pi over 4, right, Dianica? Yes. Everyone agree with those? So I did not list those answers. Whoops. Dun, dun, dun. So I think I did half the problem, and then I forgot what I was doing. 5 pi over 4. And then the other one was 7 pi over 4. All right. Thank you. Thank you. Thank you. All right. So, general solution, because it's sine, all you do is just put plus 2 pi n at the end. That's it. That's the only piece. And that covers all of the rotations. So, let me think. Let me look at the. I think I know why I didn't put those other answers. Let me look at the unit circle because I need a picture before I say what I'm going to say. Pi over 4, 3 pi over 4, 5 pi over 4. Nope. Nope, that's correct. Yep. So one thing that we could do, because it is all 4 of these, and then we're doing plus 2 pi over n. So we're doing basically the coterminal angles, right? We're just adding or subtracting a full rotation. But because this answer, pi over 4 and 5 pi over 4, is a half a rotation after. So pi over 4 plus pi is 5 pi over 4. We could actually simplify this answer further and instead, well, remember, I'm missing these two. So make sure in your general answer on your notes that you actually also put 5 pi over 4 plus 2 pi n, comma, or 7 pi over 4 plus 2 pi n. But because pi over 4 and 5 pi over 4 is a half a rotation path, apart, and then 3 pi over 4 and 7 pi over 4 are also a pi rotation apart, we could actually rewrite these answers as just pi over 4 plus pi n and 3 pi over 4 plus pi n. And then that would satisfy these angles right here. Pretty neat. And or you can just write them all, because if thinking about that is a pain, that's fine. So yeah, so we have to add in the other ones too. Where'd my stylus go? 5 pi over 4. And then this answer being the simplified form of this would just be pi over 4 plus pi n, or 3 pi over 4 plus pi n. And one way we can check our answers is you plug these values in. So if you plug in 5 pi over 4 into theta here, and then you type this right side of the equation in, hit enter, you will get 3. You, of course, probably have to convert cosecant squared into 1 over sine squared before typing it in, of course. But Typing in all of these angles into theta, hitting enter, you will get 3 every single time. And then any combination, because we are the coterminal angles, if you just do a full rotation forward or backwards, and whatever number you get, plugging those into theta will also yield 3. So good way to check. The condensing equivalence. Yeah, so on your test, I worked out some of the problems, and well, let me save that thought until we deal with a tangent problem, and I'll explain. But yeah, the on your test it lists this form, whatever this fraction is plus 2 pi, and it lists this form versus this form. Long story short. And it is on your test, it's drag and drop if you're wondering. You just, you solve it and then you just drag from the word bank into the answer. So it makes it kind of simple in that way too. So
I have a question really quick.
Yep.
So how come for the 5 pi over 4 can we do plus pi n? Like how you took the 2 out for the other ones?
Right. Okay. So my singular answer is just those two. Let me box it. And the reason why is because like pi over 4 and 5 pi over 4, those are 1 pi away from each other. So pi over 4 plus pi is equal to 5 pi over 4. So by just saying pi over 4 plus pi n, it covers both pi over 4 and 5 pi over 4 plus your 2 pi n. Does that make sense? I feel like I'm using a lot of words. Okay. Yeah, so just to draw a picture real quick. So on your unit circle, we have, so you're going to have an angle here. So you're going to have that angle, then you're going to have this angle, and you're going to have this angle, then you're going to have this angle. So those are the 4 angles that we found. Pi over 4, 3 pi over 4, 5 pi over 4, 7 pi over 4. So taking that angle and adding 2 pi times n, that creates your coterminal angle. So we have an infinite number of possibilities. So you have that angle plus 1 rotation, plus another rotation, plus another rotation, and up to infinity. So that's where that plus 2 pi n comes into play. So by us listing all 4 answers with plus 2 pi n, well, we're covering all options and all infinite options. But looking at use a different color. Looking at, let's say, these 2 angles, you have this angle and then you have this angle. They're opposites, and they're also a full rotation away. Not a full rotation, a full half rotation. So pi, they're pi rotation away, or 180 degrees. And that's why in this answer here, pi over 4 plus that half rotation gives me my 5 pi over 4. So that's why it's covering both solutions here. So I really hope all of you have a decent understanding of unit circles and radians and degrees to understand half of what I'm saying. Because if you're just doing the very minimum to maybe pass your quizzes and tests, but not fully understanding, everything I'm saying is kind of going over your head, and that's not good. So pre-calc takes time. You have to put time in this class to really practice problems and study. It's not just come to class and then you're done. So what's with the 3 pi over 4? So again, 3 pi over 4. So you have 3 pi over 4 and 7 pi over 4. 3 pi over 4 plus pi is 7 pi over 4. So there's that case. Right. 3 pi over 4 is another solution to this problem, along with 7 pi over 4. Yep. All right, let's do another problem. All right, we have negative cosine theta plus cosine theta cosecant theta minus cosecant theta minus 2 cosecant theta. So the title of this slide is common factors. So I want all of you to, I'm going to give you a hint on how to approach this problem. Don't convert anything to the fundamental trig functions yet. I want you to combine like terms on one side of the equal sign. Then from there, I want you to factor it. So greatest common factor in this case. And then once you factor it, let's go ahead and stop there. So I want you to get to the factored step, and then we'll continue the discussion. So I'll give you a minute and a half. Ready to go. Yeah, make sure you have your unit circle in front of you. We need it. All right, anybody want to use the mic to explain your steps? Or use the chat box. That works too. So Danica said we're going to add 2 cosecant to both sides. Yep, that's right. And then, you combine like terms. The negative 2 cosecant plus 2 cosecant, well, they cancel out, right? Negative 2 plus 2 is 0. So you're left with just that. All right, what's the next step? Factor. What can I factor out? Factor out cosine. Yep. Okay. All right, so now we are in factored form. What can we do next? Remember, we're solving for trig functions. Set them equal to 0. Yep. So once it's factored, set each factor equal to 0. So we have cosine theta equals 0 and negative 2 plus cosecant theta equals 0. And now from here, we can go ahead and change your cosecant to 1 over sine theta. We could have actually converted this to 1 over sine theta at the beginning, but it really wouldn't have helped us at all in these steps other than create fractions. And the only reason why I didn't do it until now is to avoid looking at fractions. That's the only reason. All right. So let's do the easy one. Cosine theta equals 0. So looking at your unit circle, what are the angles when your x value is 0? Pi over 2 and 3 pi over 2. Yep. Everyone good so far? All right. All right, next one, we're, add 2 both sides. Also convert cosecant to 1 over sine. Use that diagonal trick, which I think is amazing. Swapping sine theta in 2, saving us a couple math steps. Inverse sine both sides. And the question is, what is the angle when your y values are 1/2? Check out your unit circle. So we got pi over 6, 5 pi over 6. Yeah. So everyone can see on your unit circle, right? Y is the angle when y is 1/2 is, well, those two angles listed. Yeah. So all we got to do now is just write them all um, in general form. You're going to have pi over 2 plus 2 pi n, 3 pi over 2 plus 2 pi n, pi over 6 plus 2 pi n, and 5 pi over 6 plus 2 pi n. That covers all the, that's general solution. That covers all the coterminal angles that would make this true. That's it. Solving trig problems takes practice. It is not easy at first. That is the truth. N is an integer, and n can be anything. So I can make n1, I can make n2, I can make n3. I'm just choosing n is some arbitrary number that we choose to create a coterminal angle that when we do that, we get a new angle, like I can make n 1,000, right? And I get some really big angle. And when I plug that angle into my original problem and I type it in, hit enter, I will get a true statement. Because when dealing with trig, you have doing a full rotation creates a new angle. It looks different, but for trig, we learned about coterminal angles. Mathematically, it's going to be the same because you have that nice sine wave, right? Just repeats over and over. Yeah, so n can be anything. All right, we got 3 more slides. This one and then 2 more. Okay, so factoring a trinomial. So again, this is solving equations. This is all from yesterday, right? This is nothing new in terms of solving. The only new piece is just writing it in general form, which is kind of easy. All right, so we have sine theta plus 2 sine squared theta equals 1. So on your test, your quiz, it's not gonna have the heading factoring a trinomial. It's not gonna give it away like I just did. We know that we're gonna be factoring this trinomial because you have all the same trig functions. So we're using sine. One is just sine, Another one is sine squared, and then we also have an integer or any number really. So if it has those three things, more than likely it's going to be factoring a trinomial. So get everything on one side, subtracting one both sides. And then you also want to reorder your terms. You want the sine squared first, then your sine, and then your number. So everyone do that step. And then I'll give you time to factor this. And this is from yesterday, so I'll give you, I think, 2.5 minutes should be enough to factor this. Ready to go. All right. So go ahead and chat. Go ahead and write your factors that you found. What are your factors? Can we do, if you're still here, can you give me a thumbs up? Well, no, or you raise your hand. That's what it is. If you're still here, raise your hand. I just want to see if people are actually here because we have, it looks like, okay. We got two people not here. That's sad. All right. So People that are here, you might have to review how to factor. Um, I'll look up some good maybe Khan Academy videos of factoring polynomials and email to all of you to watch as a refresher, because this is a skill that all of you should have and should know how to factor. And I know I reviewed it last term and this term. So I'm just not really sure what's going on for the majority of the people that are here right now. There are a few, maybe you're still working on it, and I see some people are putting answers in. But all of you should know how to factor. So you replace sine with x, and then 2x squared plus x minus 1. Like, that's a very basic, I believe, algebra 1 factoring problem. So here's my work. And then I GCF to 2x out. And I GCF. So in that second binomial, that grouping, that negative x minus 1, you need to group it like that. And then you need to pull out a negative or a negative 1, same thing. When you do that, the signs of both of those terms, negative x and negative 1, they change to positive, and hence pulling out a negative. The whole point of this step is to get two matching factors in both terms, both of your groupings, and we can now pull out an x plus 1 in front. So we have x plus 1 times 2x minus 1. And then once it's factored in this step, we can replace x back with sine theta. And we only, like yesterday, like I explained, we only replace sine theta with x to begin with is because factoring a problem with just x's, it just looks easier than dealing one that has sine thetas and sine square thetas. It's just an appearance thing. All right, then once they're equal to each other, we set them both equal to 0. And then we solve them both. I'm just going to quickly go through this one. This part, a lot of you or most of you don't have any issues identifying the angles that satisfy this requirement. So yeah, it just, like Emily says, she could have done it if she replaced it with x, because it just looks easier to look at. It looks nicer. It makes sense, right? Yeah, and that's why I'm showing it this way. Your learn modules don't do this, I don't think. Do they? Anybody who's gone through those, do they replace those like I'm doing here? Caitlin says she doesn't think so. Yeah, I don't think so either. It's really up to you if you want to replace them. I think it's easier doing it the way that I'm showing it versus trying to look at sine theta the entire time. Barf. All right, so then we just write them all in neural notation. It's sine, so it's 2 pi n. All right, last two problems. All right, let's do this one together because this one's different. We have sine of 2 theta, so this is going to be different. What's our first step in this problem? And by the way, don't be tempted to use the double angle identity. Don't do that. That's not what I'm hinting you at to do in this problem. We don't want to do that. We're not simplifying a problem. We're solving trig functions. So you may or may not use trig identities, but using that one. So sine 2 theta is equal to 2 cosine theta sine theta. And if you use that trig identity, you now create a problem that has two trig functions, and um, that's not good to solve. Okay, so we divide both sides by 4. And when you do that, you get negative rad 2 over 2. I don't think that's a nasty fraction. All right, what's next? So pretend that 2 theta is not there. Pretend it's just theta for right now. What do we do next? Inverse sine both sides. Yep. So now I have 2 theta equals inverse sine of that stuff. So we're going to ignore this for right now. We're going to deal with this. So the question is, what are the angles where your y value equals negative rad 2 over 2? So look at your unit circle. What angles is your y value negative rad 2 over 2? Go ahead and write it in chat. So we got 5 pi over 4 and 7 pi over 4. I see those two answers. Those sound kind of right, I think. Everyone look at your unit circle and agree. Let's take a look. Yeah, I agree. So we got 2 theta equals those two angles. So now this is the twist of this problem. So once we're here and we got 2 theta equals those two angles, we now have to do what? Take a guess. Take a guess. No, we don't. Antonio's just like putting every combination he can think of without much thought, it looks like. He's just basically throwing darts blindfolded at the board, hoping one actually lands on the board. Yeah. So before you do any more math to this step, what should we do? Okay, after that, Antonio. Okay, before we do any math, what do we do? I'm going to give you a hint. We have 2 angles that we found. So before I do any math, I do what? Crying is not an option. Before we do any math, we should set up the equations. That's what I was looking for. Set up the equations. We have 2 angles. We should have 2 equations. 2 theta equals the first angle, and 2 theta equals the second angle. I was looking for a very basic answer there. We set up the equations. So I have 2 theta equals the first angle, and we want this in general form, by the way, sorry. And then 2 theta equals the second angle in general form. Definitely, everyone was overthinking it. Yeah, we just set up the equations. All right. And then Antonio did guess right, basically. Once they're set up, like we have here, we can now divide everything by 2. So I have 2 theta divided by 2. I have 5 pi over 4 divided by 2. And I have 2 pi n divided by 2. So, or you can think of it as multiplying everything by a half, right? Same thing. Dividing by 2, multiplying by half is the same thing. So 2 times a half is just 1 theta. 5/4 times a half is 5/8. And then 2 pi times a half is just pi. Same thing. And then same thing for the other one. Multiply everything by half. And now we're done. We have the 2 answers.
Wait, what are you saying we're doing to both sides?
Dividing by 2 or multiplying by half. Either one is the same. So let me show it. I think most people like seeing divided by 2 for whatever reason. So divide by 2, divide by 2, divide by 2. And that's how I get 5/8 and 1 pi's. So problems that involve, like it could be 2 theta, it could be 3 theta, it could be anything. Once you get down to this step, don't forget to create your equations from the angles that you found, but make sure it's in general form. Because if you forget to put, if it's, in this case, it's sine, so we have to put plus 2 pi n. If you forget to put this piece and you just divide both sides by 2, you will have theta equals 5 pi over 8, but then in your final answer, you will accidentally put plus 2 pi here instead of just pi because of this misstep. So do not forget to set it up like this. So that's the only twist in this problem. For this, oh yeah, let me give you the slides. Give me a second. Here's the last example, but let me go.
Your mic's off, by the way.
Hey, you're right. I clicked the mic button by accident. Thank you. All right. Yeah, let's go ahead and finish this problem. Oh, this is from the Learn module. I chose this for a reason. Because this problem involves tan. If you know, there's a tan here, but then there's also sine and tangents here. So starting off really easy, looking at this, there's nothing to combine. So we have a tan here and a tan here. So that's why we factored it out in front. So now I have just tan theta times this. Then from here, you set them both equal to 0. Then we solve them both. Inverse tan both sides. So the question is, what angle is tan equal to 0? Well, remember, tangent is y divided by x. So in order for us to get tangent of, well, to get 0, your y value has to be, well, 0, right? Because 0 divided by anything, well, it would be 0. So we know that your y has to be 0, x can be anything. Well, the only place where y is 0 would be at 0 and at pi. So those are the only 2 places where this would be true. Pi and 0. All right, for the second equation on the right, we're going to add 2 sine theta both sides. divide by 2 both sides. And then we're going to inverse sine both sides. And then the question is, all right, so what angle do we have y equals rad 3 over 2? Well, rad 3 over 2, we have 2 places, pi over 3 and 2 pi over 3. All right, so this is like the kind of twist they talk about in the module. Tangent, what is the period for tangent? Pi, yeah. So in my general solution, 0 and pi, are those half a rotation away? Look at your unit circle, 0 and pi, are those a half a rotation away? Remember, a full rotation is, well, 2 pi, right? So from 0 to pi, that is a half a rotation. So listing 0 and pi when we're talking about tangents, this is redundant when we do general solutions, because 0 plus pi gives us pi. Because we're going to write this as 0 plus pi n, and we would write this one as pi plus pi n. But this first one covers this angle when talking about general solutions. So that's why we only have to write this as pi n. Because, let me write this down, seeing is better than words, I think. So 0 plus pi n, and then this one would be pi plus pi n. So there's the both of them. But because it's tangent, we're always doing a half a rotation. So the first one that I wrote, 0 plus pi n, if n equals 2, it covers when n equals 1 and the second part that I wrote. And this simplified is just pi n, because 0 plus anything is itself. So that's why we don't have to write the second one. All right, so your general solution for this, you're going to have your theta equals pi n, comma, and then for these other ones, you're going to have pi over 3 plus 2 pi n, because we're talking about sine, and then 2 pi over 3 plus 2 pi n. So this has a mixture of tan and sine. Remember, sine is plus 2 pi n, and tangent is plus pi n. So there you go. And that's from the Learn module. Hopefully that made a little bit of sense. So all of you, again, should have your unit circle in front of you at all times during these lessons, because I refer to it a lot. All right, everyone, thanks for hanging around, and I hope you learned something. See you tomorrow.